What's up? Back with day 7 of review. Today we're going to review a very important topic, graphs of F prime. So we're going to go through this. Oh, also, just as a note, I posted, go to Quizlet. Check your email and follow the link in Quizlet for, I made 43 flashcards. I think I might add some to that, but it's a good start for you to be flipping through to make sure you got all your definitions down for that. So check your email for that link to make sure you're practicing that. Okay, so here we have a graph of F prime, and I'm going to ask you a lot of questions about this, okay? And most of it is review from way back in first semester, but I'm going to throw in some newer stuff with this as well. Okay, so the first question is, when is F increasing? Well, to answer this question, think about your definition. We know F increases when F prime is positive. That definition will be our justification when asked for. So F prime is positive. Well, the other thing I like to do, whenever they give me an axis and they don't number it all the way, I like to number it out just to make sure. So we got -1, 2. Okay. And this will go out to 2, 3, 4. Okay. Now, for F increasing, there's a couple of different answers that would be acceptable. We could say from -5 to 1, union 1 to 6. Or we could say from -5 to 6. If it was a multiple choice question on the test, they would say from -5 to 6. They include 0 as a time when F is increasing, when F prime equals 0. So they include, that's why they have the hard brackets, they include -5, they include 6, and they include 1. But either one will be acceptable on free response. And our justification is that's where F prime is greater than 0. Remember, they wanted to know when F was increasing. F is increasing whenever F prime is positive. So we just look at our F prime graph and report the positive regions. If they wanted to know where F was decreasing, we'd say from -7 to -5, union 6 to 7, because that's where F prime is less than 0. Okay, next question. What are the critical points of F? And I want you to label as local min, local max, or neither. Once again, we want to justify. I'd use full sentences when you justify. Right, I just wrote F prime greater than 0. I would write out on the test, because that's when F prime is greater than 0. Okay, so the critical points of F are going to be when F prime equals 0, or F prime is undefined. F prime is defined everywhere from -7 to 7 here. So we're looking for the zeros of F prime. So I would write F prime equals 0 at x equals -5. X equals +1, and x equals +6. So looking at our critical point at -5, we want to determine if that point on the graph of F is a local minimum, a local maximum, or neither. What we would do here is we would say, okay, how is F prime changing? Well, as we move left to right, F prime switches from negative to positive. That means F went from decreasing to increasing, which means we must have had a local min. So x equals -5. is a local min. Our justification is because we don't say, remember, we were hard on this back in the first semester, it's going to be for this reason, we don't say because it goes from negative to positive, we say because f prime switches, right? F prime switches negative to positive. Okay. X equals 1 is going to be a neither point. Because f prime doesn't switch signs. That means x equals 6 is going to be a local maximum. Because f prime switches plus to minus. Even if they ask you to explain 3 different critical points, carefully state out f prime each time. Okay. Next question. I'm not going to write this one out, but I just want you to listen to me on this one. When is f, on what intervals is f concave up? Well, we know f is concave up, right, from our note cards, the Quizlet note cards. It says when f double prime is positive. We don't have an f double prime graph. We have an f prime graph, so we want to use the idea that f prime is increasing. So f will be concave up from -7 to -2, union 1 to 4, because that's where f prime is increasing. F would be concave down then from -2 to 1, union 4 to 7, because that's where f prime is decreasing. What would be the inflection points of f? Well, again, the inflection points of f are when we change concavity, when f double prime switches signs. Neither of us, that helps us here. So we think about inflection points in terms of an f prime graph. That's when f prime switches from increasing to decreasing, or vice versa. So x equals -2 would be an inflection point, so would x equal 1, so would x equal 4. Again, because f prime switches from increasing to decreasing, like it does at x equals -2 and x equals 4, and vice versa, decreasing to increasing at x equals 1. Okay? So again, in summary, this point is local min. This point, neither min nor max. This point, local max. Our inflection points will be right here, and right here. Interestingly enough, x equals 1 is both a critical point and an inflection point. Okay? It's a critical point because f prime equals 0. It's an inflection point because f prime switched from decreasing to increasing. Okay? Now, one of the other things that they say let me just declutter this picture real quick. Oops. One way that we can tie in some integration to this is here's what they might say. They might say the area between the function and the curve from -7 to -5. Let's say there's an area of 2 right here. Let's say there's an area of 8 right here, an area of 6 right here, and an area of 1 right there. Right, we can't calculate those by hand because we don't know the function. We can't do the integral by hand. We also can't, they're not shapes that we know the areas of. They're not like triangles or rectangles. So sometimes they just tell you that. Those are the areas for each of those bounded regions. Okay? Now here's what they're going to tell you. Here's the problem. They're going to tell you, I'll use a different color so it stands up. They might say, just so you know, f of 1 equals 5. Tell me, what is f of 7? Okay. So here's what we need to know. What they gave us there is an initial condition. This is our initial condition. So if we wanted to find f of 7, we know f of 7 must equal our initial condition, 5, plus the integral from the x value of the initial condition to the x value that we want of f prime of x. Okay. Sometimes they'll ask a question like this. You may say, well, how am I supposed to do an integral of something I don't know? Well, that's why they gave you the area units. That's why they gave you the area of those pieces. So we know that f of 7 must equal 5 plus, now we have to do the integral from 1 to 7. Well, the integral from 1 to 7 is going to be, we have this area of 6 and we have this area of 1. What we need to remember is that this area of 1 is actually going to count as -1 because it's below the axis, whereas this is going to count as a positive 6. So the integral from 1 to 7 would be 6 minus 1, which would be 5. So it would be 5 plus 5, which equals this guy. So we can calculate f of 7. They might also ask you to find f of -5. So let's say we want to figure out f of -5. Well, again, we're going to use our initial condition right here. Well, this just has to be 5 plus the integral. Now, here's where we need to be careful. From the x value of our initial condition to the value that we want. Right? The initial condition, x value needs to be on the bottom always. F prime of x dx. Okay? Now, when I look at this, now is when I say, okay, this is backwards to me. Right? If I just had a function, I could do bump and divide and just plug in -5, plug in 1, and subtract them. But when I'm doing this by hand on the graph, I definitely want to switch the order here. So what I'm going to say is this equals 5 minus the integral from -5 to 1 of f prime of x dx. Now I simply need to do 5 minus whatever the integral from -5 to 1 is. Well, the integral from -5 to 1, that is the number 8. So my answer is 5 minus 8, which equals -3. Another question they might ask is, okay, find the absolute maximum value of f. Let's say that was the question. Find the absolute max value of f. Let's do both. Absolute max and absolute min. Again, they might not say absolute. They might say the maximum value and the minimum value of f on the interval from -7 to 7. Okay? Well, again, in my absolute max, absolute min video, we talked about we need to check all the endpoints and all the critical points. So I'm going to make a table. And what I want to do is I want to check the endpoints of -7 and +7. Plus, I want to check all the critical points. My critical points are -5, 1, and 6. Okay. Now some of these values I've already calculated, so I'll put them in. F of -5 is -3. I calculated f of 7, I believe. Yep. F of 7 I got to be 10. F of 1 was already given to me. F of 1 equals 5, right? That's our initial condition. We can just use that. So I need to calculate two more. I need to check f of -7, and I need to check f of 6. Let's do f of -7 first. F of -7 is going to be my initial condition of 5, plus my integral that goes from 1 to -7 of f prime of x dx. Once again, that's the wrong order, so this is going to be 5 minus the integral from -7 to 1 of f prime. The integral from -7 to 1 will be -2 plus 8, which will be 6. So I got 5 minus 6, which equals -1. Doing f of 6 then, f of 6 would be 5 plus the integral from 1 to 6 of f prime. I don't need to switch the order here. The integral from 1 to 6 is 6. So I've got 5 plus 6, which equals 11. So 11 would be my max value. -3 would be my min value. So that combines an f prime graph with some initial condition integration stuff that we're used to. Right? So they love to combine different topics into one free response question. Okay, that's it for today. I'll talk to you guys later. See you tomorrow for With Calculator Wednesday. 2 chains. Bye.